Alrighty, I guess I will get going. We are recording. Okay, well, hello everyone. My name is Hannah Dromiack. I will be giving today's Proteus TV episode. I will be discussing life in a very philosophical way with some of the work that I am doing on attempting to quantify it. So feel free to ask me questions in the chat. I am about to pull it up so that I can see it. And do not be shocked if there is lots and lots of questions that I ask you that have no answers. Okay. Alrighty, so life. ... The best way I think to discuss life is to start at the beginning and work your way up. So, the story so far is in the beginning, the universe was created. This did make lots of people very angry and has been widely regarded as a bad move. So this is Douglas Adams from our Hitchhiker's Guide to the Galaxy. And in two sentences, he's managed to sum up quite a lot, and you can really get into the nit and grit of it. But in essence, that's what happens. So you have the universe is created, and at some point, later on after its creation, you get to a point where there's something within that universe which is no longer just this ideal, box full of bouncing balls. It's actually something that's capable of questioning its place in the world. And that's why this quote has a lot of meaning, actually, because the last little couple words you have is it's been widely regarded. So there is something in a universe capable of questioning not only the universe, but its place in it, which is very weird and very strange. So it would be like your liver becoming sentient and trying to figure out its role in your body with limited information, with, in this case, no technology on its side, and it would be trying to figure out, okay, what's coming in, what's going out, what is my universe? So we are maybe not as significant as the liver, but like the liver in terms of the universe. And we're trying to question what life is and what our role is in all of this. So it's big philosophical stuff. It's quite crazy, really. So we now get to ask these questions that are insurmountable in their requests, but exist nonetheless. So this is Sarah Walker's big question, and many others. I think Schrodinger also has said it, but what is life? And this is really broad, very big, hard to digest. So I'm going to break it down into stuff that I prefer. And so one of it is the smaller question of what are the properties of life? What actually distinguishes life from everything else? What is the defining pieces that make it life versus, just rocks or, just things flying around some void? So we can break this down even further and talk about what is living and what is non-living. We're still pretty abstract in this, and that's because it's hard to define that line. We don't really know what it is, and we have to create it. So for the sake of this lovely little digesting we're going to assume we do know it for this moment. For a moment, we know what's living, what's non-living. We can intuitively look at a rock and say it's not living. We can intuitively look at an ant and say it's living. So now the next question is, how do we quantify this? How do we actually take what we know to be non-living and living and make a metric that we can actually use so that we can actually, go somewhere else and determine if there's life? How can we mimic life? How can we actually take what we see around us and the world we see and make it intuitive and understanding to us? And I want to say for the quantifying aspect of it as well, to make sure not to get too abstract on that front, because science was made by us for us to be used by us. So in this sense, quantifying it is going to be quantifying it in a way that we can understand and we can interpret. So any really, what if aliens don't think we're living? I'm not doing this for the aliens. This is for us. Alrighty, and finally, just to close out our little loop here, which are we? Once we figure out the metric and we figure out ways to quantify life, where do we fall? Are we living? Are we non-living? So, that's that's up there with the what is life in essence of philosophical questions that may or may not ever be answered. But I am going to say that I love our big, deep philosophical ones of what is life and which are we, but I'm not overly interested in them. So I'm going to be focusing on what are properties of life, and then how do we distinguish them from non-life, and how do we make it useful? Alrighty, so what is life? That is for a future generation to truly define. And then which are we? Honestly, you're going to live your day whether you know you're living or not. So we'll leave that up to the philosophers. Alrighty, so we're going to go into these little boxes. So first off, what are the properties of life? This is up for debate and has been since the dawn of human civilization practically. Aristotle, Plato, I apologize, Plato, Socrates, everyone has kind of questioned this all the way up to modern philosophers. So we got to start somewhere. So I'm going to take what the scientific community way back when decided were the rules of life. And we're just going to start here. Trust me, we're going to move on beyond this. But to give everyone a base in which to kind of like spur from, these were the 6 rules of life from biology. Most of you probably learned these at one point or another in your young education. Everyone likes to cover it at least once, but here are the basics so far. These were the lines that we drew in the sand. So life responds to the environment. What that's entailing is the fact of the capacity to actually interact with the environment. So if you have a wave rush over you, you're able to react to that, and you get to make decisions and choices based off, if that wave is coming at you, what are you going to do? Or temperature gradients, what happens when cells are introduced to hotter environments, what do they do? So it's the capacity to respond to stimuli, okay? The second one, life grows and develops. Think embryos, think of when babies form into small humans and small humans come into adults, and, life gets hard after that. That's been a rule for life. Can it grow? Can it develop? Then finally, offspring, once it's developed itself into a sustainable individual in their community, can it produce offspring? So that can either be through mitosis or meiosis, so sexual reproduction or copying yourself. And it's a pretty important factor of life in the sense of making sure that you continue life and life doesn't just pop up and then vanish. And then homeostasis, so are you stable? We'll not discuss mentally in any way, shape, or form, but will you turn into a blob of goo? Will all your parts fall apart? If you are stable, you shouldn't do that. And then finally, these last 2 ones are kind of my favorite, is complex chemistry. That's more of an observation. So life, as we've seen it, requires complex chemistry because to do even the simplest things with life is very hard. So if you take a plant, for example, if you learn the basic digestive kind of track is plants breathe in CO2 and they, spit out O2. Now that chemical process to change the CO2 to O2 is quite complicated in itself. So you have to consider the fact that you need more complex chemistry to do that. And so life generally has complex chemistry. And then finally, life consists of cells. So cells are our basic unit of life that we have determined, at least here on Earth. I do want to change 6 just a smidgen, just to make it a little bit more general, is life consists of fundamental units of life. I'm leaving it general for the sake of, we've never been to another planet. Who knows? Maybe life is very, very different elsewhere. But these are our rules to date. Alrighty, this is what we know life to be. Now, there's debate still ongoing. These rules are by no means set in stone, but it's as good a place as any to start. So these, for me, bring up lots of questions because my goal is to make life distinction practical and, a quantifiable thing. So first off, are these properties enough to describe life? Can we actually take all form of life, everything that we know it to be, and describe it with those properties? Okay? So you guys can think about it, digest. Then the question comes after that, are there more properties to life? Are there more ways to discuss life that are more productive, more helpful? Do they produce better results? Then my two favorite are can any of these be quantified? Can we actually make metrics to look at and make clear distinctions between what is life and what isn't life? And the reason that this is very important is because this is how we bring our understanding, our intuition into how do we turn it into technology, how do we turn it into mechanisms to find things. We're trying to bridge our inherent intuition as living creatures into technology. And then finally, are these properties exclusive to life? So reproduction, is that only something that occurs in living systems? Growth, is it only something that occurs in living systems? So are these properties exclusive to life? Which you will find they really aren't. So if you look at them, growing, many inorganic minerals actually grow. They don't, change their structure usually, but they do actually show growth. Homeostasis, stable equilibrium. A lot of systems that are not living do that. Complex chemistry. Now, life has complex chemistry, but it's not the only thing to have complex chemistry. There are non-living systems that have incredibly complex chemistry. Response to the environment, that's a debatable point. You can definitely make some arguments concerning non-living systems responding to the environment. But as you can see, these are not exclusive to life. These are very much properties that are shared between the two. So they're a lot harder to state, I found something that has homeostasis. Is that life? Well, maybe. So in essence, what I'm getting at is that I would like a property that is exclusive to life. So that is my big question. Is there a property exclusive to life? So that means no non-living system will have this property, okay? Now, I have an idea. So now from this point on, I'm putting this out there. These are my ideas and my research, and so it may not be the right answer, but this is the path I've chosen to go down for the foreseeable future. So we will see what happens to it. So a property that is exclusive to life is something very hard to quantify, and that is behavior. I am talking a lot faster than I thought I was. Alrighty, so behavior. This is a property, so behavior, to kind of define it in these terms, is the capacity to make decisions. And I'm going to avoid getting into the philosophical discussion of what is a decision or what is that. So I am defining this in my research, as something capable of choosing. And so what this means is that living systems actually have a capacity to choose something in their environment. They can respond to the environment, take information in, and then have a resulting action that doesn't only depend on if you rolled a ball down a hill. If that ball is living and maybe it has legs, it can go up the hill instead. But there's the capacity to choose to actually have a property that's beyond a non-living system. And so this is behavior. It's very hard to quantify. So I'm going to explain to you how I am kind of the thought process for how I am going to try to quantify behavior. Also, that being said, if you guys have any other good ideas, feel free to throw them in the chat, and we will get to them. But alrighty, so this is my research. This is a really surface level, kind of high level, discussion of it. So what I do is I am taking trajectories data, so time series of spatial coordinates of a system, both living and non-living. Then what I've been doing is coarse graining it in different ways. So first, let me describe the coarse graining. So the coarse graining is similar to a Fourier's transform. So between spatial space and momentum. So when you do an integral to move it into a different space, that's kind of what I'm doing here with the coarse graining. I am coarse graining the spatial coordinates into different spaces. One of them I have dubbed behavioral space, I think it's a correct name, where I take the trajectory and I deconstruct it in terms of decisions. So based off certain thresholds and different time histories, you will get a decision. And the decisions we're working with right now are left, right, and stay the course. And so that discretization allows the spatial coordinates to be moved into a more abstract space that allows us to do different types of metrics and analysis on. So that's the third step. It's going to be taking these new time series full of decisions or other types of spaces we move into and actually trying to identify a metric within them. I am currently at the coarse graining phase, so this phase right here is where I'm at. The identifying the metrics, this is to, in essence create, as Josh kindly named it, an agency turning machine or a life detection model. And this is being done, the identifying metric is going to be done with both information theory and a new theory that's being developed called assembly theory. And so each of these are providing some basis by which to actually draw a line between a living system and a non-living system in a new space that is a little bit more abstract beyond just the spatial coordinates. And the reason this is a really interesting, what would be an example of a metric? So with information theory, I'll go with that one. So a design metric would be like if we're seeing in like collective behaviors, as you might know, they do a lot of information theory with like mutual information and transfer entropy between agents and collectives. What you could do is make a metric based off of like how much of that you see. So if you see a certain, amount of transfer entropy between two agents in a collective, you could make a statement that, given this and this, you have some % chance of it being a living system. So, but thank you for bringing that up, so I should clarify that. The identifying of the matrix, the metrics is that it will not be something where we can definitively say. I mean, getting 100% confidence in just about anything is next to impossible. So in essence, what this is trying to do is provide a new way to discuss living systems and to say with like, if you were to look at a system and analyze its data without knowing anything about the system, you could potentially have, like, say, you analyze a whole system and it falls within a certain aspect of this yet to be created metric, you have a 90% chance of it being a living system. So it's kind of, instead of trying to give definitive answers, it's giving you a target in which once you hit that target, you can say something about the system. And this type of metric is also going to be good for supplementary stuff. So if you have more information about a system, the better your accuracy on hitting that target is going to be. But I'm trying to, at least on the front end, make it a little bit more abstract so that you don't have to depend on having all of this information. Like, you wouldn't have to go out into the wild, look at a monkey and be like, okay, I now have this data and I know it's a monkey. So that's how I know it's a living system. You can go in and you could take a trajectory and potentially, reduce down to finding out, okay, there's an 80% chance it's a monkey. So if that kind of makes sense. And feel free to holler if I need to if I need to describe better. I have learned recently that my brain does not always think quite linearly. Alrighty, so I think next up, okay, so all this being said, this is still very, very new research, so a lot of it is still being, I'm still working on most of it and developing a lot of the forefront theory on it. But one of the things that I particularly aim for is I like practical, I like useful, I don't like, I'm not a huge particular fan of science for science sake. I prefer science to also have a practical application because I think it ties in the world to science and the science to the world, and it kind of keeps this nice balance. And so what my goal is for this is a usable means or theory to develop for behavior so that it can be used. My main focus currently is life detection. So that would be, could we take data from, say NASA missions or other missions to go to ocean worlds? Can we take data and actually use that data to, say to some degree, there is a 70% chance there's life on this body, or, there is like, at least based off what we have, like 0% chance, kind of start making ways to do life detection that are not biased towards life on Earth. So that's one of my main goals right now. The other one, this is a plug for, this is a plug a little bit for the AI people, is that the more that we understand how living systems operate and the algorithms that they can use and such, which this will help with, is the better the AI will be at, understanding life, creating new life, and doing, bio-inspired robotics and such, because this will be another way to look at living, systems. And so these are the two plugs that I was doing, but I do believe there's many, many other uses for these kinds of metrics and this kind of research, which is not limited to just the trajectories or just the just these types of metrics. It's just the beginning. Okay. Alrighty, so to wrap up this whole idea, this was a very quick talk, but I wanted to make sure we had a nice little bow at the end. So, what property is exclusive to life, and can it be quantified? My personal opinion as of right now, until my research proves me right or wrong, is behavior. Using behavior, what is the method for quantifying this, this property at the moment is coarse graining and transformations, and using theories that, like information theory and assembly theory, and just various theories that have been developed, or potentially developing a new one if required, for quantifying this behavior and making it accessible and usable so that you can take different types of data and actually, apply it. And then finally, can it help answer the questions that life has? So life, in this case, is us. We are asking these questions, which is just weird, and we want these answers. So can it? Maybe. TBD on that. I hope it can. But yeah, we will find out in the future. Alrighty. So questions. I know this was a really fast Proteus TV today, but I'm happy to take any. I'll give it a few moments in the chat. I realize I talk a lot faster than I thought I would. Okay. Alrighty. Well, that was my very quick philosophical discussion on kind of some questions regarding life and the answer and the ways I'm trying to go about answering some of them. And I think that is about it for me today. If anyone has any questions or wants to say hi in the chat, sorry if I'm looking off screen, I have two computers running. Okay, well then that is it. Thank you guys all for coming. Well, thank you. I will probably see some of you in the meeting in a little bit. Alrighty, so see you guys when I see you, and thank you.